So the first one we have is 2y equals 7x minus 6. Now, standard form looks like ax plus by equals c, where a is just a number. Specifically, though, a has to be a positive number. Your x term should be positive. B is some number. Now, that one can be positive or negative in the sense that it could really be ax minus something times y. So it'll be a positive number, but it might be subtracted. And then c, again, is just some number. So our goal is to put it into this form right here. So since we can see that our x and our y are on the same side, first thing I want to do is put my x term and y term on the same side. So I have 2y equals 7x minus 6. So the first thing I would do is probably subtract 7x. Subtracting 7x from the right-hand side just gets rid of the 7x, right? And then subtracting 7x from the left-hand side, I have negative 7x. Now notice I put negative 7x instead of 2y minus 7x. Why? Right, standard form is not by plus ax. It's always ax plus by. Your x term has to be first. So when I'm subtracting it, that just means it's going to be negative 7x plus, since it's positive, it'll be plus 2y equals, and since what's left over here is the minus 6, it'll be equals negative 6. Now, this is almost standard form with one exception, which is this is negative 7x, and I want positive something x. So, very easy way to take care of that, though. Yes? You multiply by negative 1, okay? You could also technically think of it as dividing by negative 1. It gives you the exact same result. Multiplying or dividing by negative is going to change the sign. Multiplying or dividing by 1 isn't going to change the number. So, if I multiply by negative 1, the important thing to know is I have to multiply all of it times negative 1. So it's not just negative 1 times negative 7. It's negative 1 times negative 7x and negative 1 times positive 2y, right? So really what multiplying through by a negative is going to do is it's going to change all of the signs. It's going to make the ones that are negative positive, so I'll have 7x. And it's going to make the one that's positive negative, so minus 2y. But again, since it's equal, if I multiply this side times negative 1, I also need to multiply this side times negative 1, which would make that positive 6. So standard form, we have 7x minus 2y equals 6. All right, let's look at another one. So number 2, we have negative 3x minus 13y plus 2, equals, I forgot my equal sign in there. Boop. All right. So, negative 3x equals negative 13y plus 2. So once again, the first thing I know is my x and y need to be on the same side. So since 13y is over here with the constant, my goal would be to move that over. So since it's negative 13y, that means I'm going to... Yeah, I'm going to add, not negative, I'm going to add 13y to get rid of the negative. So I'm going to add 13y on both sides of the equation, on the right hand side, excuse me, it will just cancel out. Negative 13y plus positive 13y is just 0. So on the right hand side, I'm left with 2, positive 2. And on the left hand side, I have negative 3x plus 13y. Again, my x term comes first, my y term comes second. So something involving x plus something involving y equals 2. Almost standard form, but one exception. My x is negative. And again, if I just multiply through by negative 1 here and by negative 1 here, then essentially all I'm doing is switching signs. Negative 3x becomes positive 3x. Positive 13y becomes minus or negative 13y. And positive 2 over here becomes negative 2. And now it's in standard form. Now, let's look at one that has a fraction in it. So let's skip down to, we'll look at number 4. So this one we have 3/5 x minus 2 equals 4y. So again, my first step is I want to get rid of, I want to get the x and the y on the same side. Really, I would probably move this term over to this side because y is all by itself over here. So if I move the y over here, then I'm going to have x and y and my constant here. And then I'd have to do another step to move the constant to the other side. So to save yourself some steps, it's more helpful if you just move the one to the side where the other one is so that that's all that's on that side. Does that make sense? So, I could subtract 4y, but then I'd have 3/5 x minus 4y minus 2 equals 0. And then I'd have to do an extra step to then add 2 to the other side. So my preference would be to subtract 3/5 x from both sides. And then if you really like having it, since you want it in that ax plus by equals c form, if you want to switch the sides, then you can. So, what I have left on my left-hand side is negative 2. I'll just write that on my right-hand side. And then on the left-hand side, I have negative 3/5 x plus 4y. So I just swapped the sides just to make it look more like what we're used to. Now, is this in standard form? No. Okay, obviously not, because we have not only a negative but a fraction. So, what's the easiest way to get rid of a fraction? Does anyone know? There's a really simple way to get rid of that fraction. Matt?
Multiply it by its denominator.
Exactly. Multiply it by its denominator. Because let's look at some examples. Let's say I have 2 7s. What happens if I multiply that by 7? No, think about it. 14 over 7, which is 2, right? Let's look at another example. Let's say I have 3/9 times 9. Someone tell me what that is.
27/9.
Which is, okay, let's look at another one. Let's say I have 3/8 times 8. Anyone notice a pattern here? I mean, think about when we're simplifying, we're multiplying fractions, you can simplify something from the top and the bottom. Well, if I multiply times the denominator, then this has a factor of 9 and this has a factor of 9, which is, which is 3 over 1 times 1, right? Same thing here. Those have a common factor of 7, which means that's 1 and 1. So I have 2 times 1, which is 2. If I do this, 8 and 8 have a common factor of 8, which gives me 3 over 1 times 1, which is 3. If you multiply times the denominator, your answer is going to be whatever that numerator is, right? So, if you look back at this one, the easiest way to get rid of that 5 is to multiply by 5, okay? Once again, just like when we're clearing a negative, I need to multiply the whole thing. And if you want to save yourself a step, you know what else you can multiply by? Negative 5. That way we're doing 2 things at once. We're getting rid of the fraction and we're getting rid of the fact that our x is a negative value. So if I multiply by negative 5 on both sides, this times this is 3. Remember, if you multiply a fraction by its denominator, then your answer is the numerator. But since it's a negative times a negative, it will be a positive. So this will be 3x negative 5. Now remember, you still have to multiply negative 5 times everything. So negative 5 times 4y is negative 20y. So it will be minus 20y. And then negative 2 times negative 5 gives us positive 10. Oop. There's something stuck on my screen. I'm not scribbling on purpose. I'm just trying to get that thing off my screen. All right, so standard form for this one is 3x minus 20y equals 10. All right, I'm guessing you would probably like to see another fraction one, wouldn't you?
Yes.
No? You feel good about it?
No, I don't feel good about it.
All right, we'll do one more fraction one and then we'll move on. Okay, we'll do one more fraction one. I got at least one person who'd like to see one more fraction one.
Yeah.
So, all right, let's look at number 10. Number 10, we have 4x equals negative 21 plus 1/3 y. So to solve this one, the first thing I'm going to do is
Minus 1/3 y.
I would subtract the 1/3 y. That way I'd put the y term on the same side as the x. That cancels, so I get 4x minus 1/3 y equals negative 21, right? Now, in this case, it's my y that has a fraction, but standard form, all of our numbers need to be whole numbers, so I still need to clear that fraction. So what do I need to multiply by? 3. Not negative 3 this time, though, because this can be negative. This one can't. This one is positive, so if I multiplied by a negative number, it would turn it negative, right? So if my x term is positive, then I don't want to change that. So I just want to get rid of my fraction, which means I'm going to multiply by 3 on both sides. So 3 times 4x gives me
12x.
12x. 3 times negative 1/3 gives me,
3.
now remember it's the numerator that you keep,
Oh.
okay? Again, think about it. If you do 3 times 1/3, the 3 and the 3 are going to cancel out, right? Because they have a common factor of 3, which leaves me with 1. Okay, so whatever your numerator is, that's what's left. And since it's a positive times a negative, it would be minus 1y, or just minus y, equals, and then negative 21 times 3 is negative 63. So that would be this one in standard form. All right, so y'all get the basics of how to put it in standard form? Okay. Okay. What did you do, just out of curiosity? Okay, so you just did an extra step. You multiplied by a negative, and then you had to multiply by -1 to clear the negative. Yeah. All right. Okay, so now let's get into the why do we want to have formulas in standard form, or why would we like to have them in slope-intercept form. Okay, so there's two different forms. Why are there two different forms? Well, standard form is more useful for finding x and y intercepts, which is one way we can graph an equation. So let's look at that for a second. All right, so let's look at some examples of what an x and y intercept are. So for this, let's look at a graph. All right. All right, so let's say we have a graph. Now, we're going to look at how to graph lines in several different ways. And the thing, guys, that usually gets people on this unit is the fact that we're going to learn like 3 different ways to do something, and you have to keep up with which way is which, okay? Usually people do fine on each section individually, but when I get to the test and I'll ask you to tell me the x and y intercept, well, when we've learned slope-intercept form of a line, people will start telling me that the slope is the x-intercept, and then, you know, they'll get them mixed up. So you really have to make sure you pay attention and keep up, because there's a lot of stuff in this unit. So let's talk about what an x and a y intercept are. Now, this unit is on linear equations, okay? In other words, they're equations that can be represented by a line, and we'll be seeing very shortly why it is that we can represent an equation with a line. But if we look at this linear equation, it has an x-intercept and a y-intercept. The x-intercept is where it crosses the x-axis. So if you look, our x-intercept on this graph is right there, which would be where x equals what? -3, right? The x-intercept is at x equals -3. Then we also have y-intercept, which our y-intercept is kind of in between, but it's somewhere in between. It's up 1, 2, 3, and a little bit, maybe like 3.5, 3 1/3, something like that. Okay. Now, let's look at another line for a second. All right, so there's another line, and then let's look at one more. All right, now all of these lines have x and y intercepts, right?
Yes.
Now, one thing we're going to have to learn is how to find an x and a y intercept by looking at an equation. Allison, Paris. Now, let's name these. So you guys did some graphing, so we should be able to name coordinates, right? So what would be the name of this coordinate right here? The coordinate.
Oh, 1.
Okay. If you were going to graph it, what would be its name? How would you find it?
Oh, x and y and...
Right, x and y, so what would be its name?
Coordinate xi?
No. xy could be any coordinate. This coordinate specifically.
Oh.
I can't see.
Right here.
2, 4, 0, 0, 4, 0, 3.5, 4, 0.
All right.
0, 4.
Which direction do we go first?
X.
On X. So where am I going on X? Nowhere. So my first coordinate should be 0. Then the next thing we're going to do is go up. So my Y is going to be positive 3 and a little bit. So we'll just say 3.5. It's probably a little shy of that, but all right. My point's not showing up very well. It looks like 35. All right, 3.5. All right, let's look at this one down here. What is this one's name? All right, -3, 0. All right, so let's look at another. Let's look at this here. All right, what's the name of this coordinate right here? -1, 0. What's the name of this one here? 0, -1. All right, and then we have one last set of, we've got this one and this one. All right, so who can tell me what the coordinates for this one are? Okay, good. 0, -3. Because we're going left or right, none. That would be 0. And we're going down, so -1, 2, 3. All right. And then this one here would be 4, 0. 1, 2, 3, 4 to the right, so +4, up or down, none. All right. Now, the one thing I want us to look at is our x-intercepts and our y-intercepts. Our x-intercepts are where it crosses the x-axis, right? So we have this x-intercept, which is -1, 0. Oh, no, excuse me, -3, 0. And this one, which is, and this one that is. All right, what do you notice they all have in common? Specifically, the y is 0. Can anyone tell me why that is? Delson?
Why the y is 0 is because they're all on the x line, so that's why they're not going up or down.
Exactly. Okay. In order to be the x-intercept, that would mean that it cannot be above or below the axis. And if y is positive, that means it is that many units above the x-axis. If y is negative, it's that many units below the x-axis. So if y is 0, then that means it is on the x-axis, right? -3, 0, -1, 0, +4, 0.
0, 0, the origin.
Yes, 0, 0 is the origin, because that would be up or down none and left or right none, right? Okay. Now, the second thing, let's look at our y-intercepts. So y-intercept means it's on the y-axis. Look at our values here. This is
0,
0, -3.
0, 3.
Okay. What do we notice about all of our y-intercepts? They all have 0 for their x. Why is that?
Because they're all on the y.
Okay, so why would being on the y mean your x value has to be 0?
Because you're not to the right or the left.
Right, again, our x coordinate tells us whether we go left or right, and going to the left or right is going to put you either to the right of the y-axis or to the left of the y-axis, which means if your x value is 0, that you are not left or right, you are on your y-axis, right? So, important thing to know here is that our y-intercept is where x is 0. Our x-intercept is where y is 0. So it's kind of backwards, okay? We're going to be crossing the x-axis if y is 0. We're going to be crossing the y-axis if x is 0. Now, what that means for us as far as graphing goes, if I wanted to graph something using x and y axis, my x and y intercepts, if I give you an equation, let's say 7x minus 2y equals 6. And I ask you, what is the x-intercept and what is the y-intercept for this equation? So, what do we know about the x-intercept? The x-intercept is
7. Oh, 2. It's
No.
2. 2?
What do we know about the x-intercept? That the y value equals 0, right? We looked at several different x-intercepts, and every time it crossed the x, your y value is going to be 0, right? So, if I look at this equation, if I want to find out where my x-intercept is, it would be where y is 0. If y is 0, then this term just goes away, right? So x would be 6/7, because I would have to, I'd have 7x equals 6, divide by 7. Now, most of the time for graphing, they're going to give you numbers that come out neatly, so it'll be whole numbers to graph. But for this equation, if you were to actually graph it, its x-intercept would be at 6/7. So you would go to 6/7, or not quite 1, right? 6/7 is almost 1. So you'd go to not quite 1 on your x-axis, and that would be where your x-intercept was. Now, if we wanted to do our y-intercept is where my x is 0, which means this is the one thing I don't like about this program. I gotta erase and do that. So if I do this, then if I want to find my y-intercept, then x is 0, which means that, oops, can somebody go wiggle the mouse on my computer? It does that.
How is this different?
It's good. All right. So y-intercept is where x is 0. So that means if x is 0, then 7 times x is 7 times 0, which is just 0, right? So basically, that term just goes away, and I end up with negative 2y equals 6, which means y would equal
6 halves.
6 over negative 2, which can be simplified to negative 3, right? So this equation, 7x minus 2y equals 6, has an x-intercept of 6/7 and a y-intercept of negative 3. Or if you wrote them as an ordered pair, the x-intercept is 6/7, comma, 0. Because remember, x-intercept is where y is 0, right? And your y-intercept is 0, comma, -3. Everyone follow where those came from? Okay, so to find our x-intercept, we replace x with 0. Well, to find our x-intercept, we replace y with 0, which basically just means, in standard form, that y term just goes away, and you get 7x equals 6, which you can divide by 7 and get x equals 6/7. So x is 6/7 and y is 0. And then for our y-intercept, we let x be 0, and then we get -2y equals 6. Divide by -2, and you get 6 divided by -2, so y is -3. So our intercept there is 0, -3. Now, we could then actually graph these. So let's do that here real quick. So if I wanted to graph these, then I would have 2 points to graph. I would have 6/7 0, so that means I go to the right almost 1, right? And up or down 0. So I'd have 1 point that would be right around here, just before. And then I have my y-intercept is 0, -3, so I go left to right none and go down 3. These 2 points are my x and y intercept for the line that represents that equation. So then to complete this line, all we would do is actually connect those 2 points. And this is the linear equation that represents the graph 7x minus 2y equals 6. Now here's what's cool about a linear equation. How many solutions are there to 7x minus 2y equals 6?
A lot.
A lot. How many is a lot?
Like 50.
50? 50. There's an infinite number of solutions. Think about it. If I pick an x value, any x value, 1, 2, 3, 4, 0, -18, 27, 172, whatever I pick for my x value, if I plug that in, can I solve it for y?
Yes.
Yeah, no matter what x value you pick, if I just plug in an x value and solve that equation, I can find a y value. Because this is an equation that has 2 variables, let's think about a really simple example for a second. Let's say we have x plus y equals 5. All right, this is a very, very simple linear equation. Let's think of what some solutions are. We could have 2 plus 3 equals 5, right? That's a solution. So x could be 2 and y could be 3. Or I could have 3 plus 2. I could have x be 3 and y be 2. Or I could have 1 plus 4 or 4 plus 1.
You could have 0 plus 5.
Or 0 plus 5 or 5 plus 0. Or 2.5 plus 2.5, because nobody said we had to have whole number solutions, right? Or
Negative
1.4 plus 3.6.
-3 plus 7.
All right, or
No.
X
Oh,
can't be.
8.
yeah, -3 plus 8 or 8 plus -3. There are an infinite number of solutions once you get to equations that have 2 variables. Now, what that means, now here's the cool thing about them though, even though there are an infinite number of solutions, all of those solutions are going to lay on the same line. So that's what we're learning to do in this unit. We're going to learn how to graph every single solution to this linear equation. Because let's look at if we, just really quickly, let's draw a graph for this. All right, so let's talk about what some of those values we said that would work for. We said x could be 2 and y could be 3. So I could have 2, 3, right? But I could also have x be 3 and y be 2, right? So I could go out 3 and up 2, right? I could have x be 1, which means y would have to be 4, right? Or I could have x be 4 and y would have to be 1. Or I could let x be 0, which means y would be 5. My line's not really straight there. Or x could be, y could be 0, which means x would be 5. What do you notice about all these points? They're all in a line. And it's not just whole numbers. If I let x be 2.5, then y would be 2.5, which puts it, boom, right smack dab in the middle of that line, right? So the really cool thing, guys, the really cool thing about linear equations is that all of our solutions are going to lay in a straight line. So what we're looking at when we're graphing using like x and y intercepts is if you find 2 points that are on that line, you can just draw that line, and that line represents every possible solution. So when we look back at this one here, even though I only found 6/7, 0 and 0, -3 as solutions, any other point that is on this line is going to be a solution to that equation.